Ladies and gentlemen, welcome back. Please welcome Chief Strategy Officer, Local Motors, Justin Fishkin.
Welcome back from lunch, and thanks for having me to the Connected Car Expo. First of all, how many people have heard of Local Motors? All right, so about half. I can give a little bit of a recap and then let you know what we're up to. The thing we need to start, does everybody here know what this is? If there are people who don't, ask your neighbor. That's right. It's the telephony's answer to car sharing, right? It's sort of something that has come and gone in the telephony or telephone industry. I want to talk about hardware as it relates to the connected car as opposed to software. I think we're doing a lot of talking about software, which is obviously a critical piece of this. But at Local Motors, we're thinking about this from a hardware standpoint. And if you really start to think about it, telephone has gone from the telegraph to these computers we carry around in our pocket in just over 100 years. It's a lot. It's a lot of progress. Totally different platform. But when we think about automotive, and obviously this is simplified, for about 100 years we've been doing things incrementally better, but on a fundamentally similar platform. 4 tires, primarily combustion engine, made on an assembly line, and we need to increase the pace of that development if we want to begin talking about the connected car. So Local Motors is based on 2 pillars. The first is what we call co-creation, where we're an open source company and have designers, engineers, enthusiasts, and fabricators all over the world that help us engineer and design our cars. Our first car, we had about 7,000 participants from 120 countries help us. Second part of our business is micro-manufacturing. So we make the cars locally that are driven locally. About 3,000 units in any given micro-factory for a local market. If you really think about it, sort of what enables the first side of that is the digital CAD that people use to engineer vehicles. And now that 2 people can work on the same CAD model in the cloud, that was sort of the first step. And the second step was being able to take that CAD data and send it to a third place and make something to your own spec. And we'll talk about that in a minute, but our proprietary process is called direct digital manufacturing, and it starts with ideation and it ends with a direct digitally manufactured product locally. How do we go back? These are our microfactories. They're open to the public. They're like experiential dealerships, and people don't just help out online, but they come in and they participate with us at the microfactory where we do sort of point of sale making of the vehicles. These are pictures of Phoenix location, our Las Vegas location. Bottom left is a partnership we have with General Electric where we do their appliances, their home appliances using this same method. And you'll see in the next year us rolling this out to some other verticals with GE. And this is sort of the so what factor. All great cars that we're comparing to, but if you look at Local Motors' first vehicle represented with the light blue on the left, we were able to bring it to market about 5 times faster than some other vehicles, and we were able to do it at about 100th the cost. And we believe that's because we have so many more people coming to the table and iterating over time with each unit that comes off that we produce. And like I said, the Chevy Volt, Fisker Karma, and the Tesla Model S, all great cars. Fisker, as we know, went out of business, not because they didn't have a great car, but because there's so much capital that goes into putting that first car on the road. What's not on here, and I'm sure the Tesla people in the room are sitting here saying it in their minds, is that we can't make 1 million cars. But we view that as our competitive advantage in the sense that we're not having to invest $5 million up front. And we're just making each unit or each car for a local market, and then we're iterating. So every vehicle that we make is a little better than the last because it's open to the general public to keep suggesting how to make it better. This was the first vehicle we put on the road, the Rally Fighter. And it's a cool car that everyone has a reaction to, either loves it or hates it. Our metric for it is it gets about 7 pictures per mile. So people will pull up next to you and almost get in an accident with you because they're trying to take a picture. Guy in the top left is Sang-Ho Kim, a South Korean student who was the primary designer of the vehicle. His name goes on the side of every unit. And like I said, about 7,000 people helped in the initial design once he submitted it, and it was chosen by the community as the winner. And we brought that to market in Arizona. Now it's driven in China and Middle East, and it's a fun car. So what's really unique as it relates to the connected car for bringing hardware to market so quickly is that it keeps up with the cycle times of the software side of things. And so if it's sensors or if it's specific hardware pieces that you need to enable the smartness of the vehicle, we're able to do that on a weekly or monthly basis with each unit that we make. And so early on, we were partnering with some of you in the room to test new technologies. And we were doing it in rooms like this with hackers who would come and help us develop the applications, try to make sure that they couldn't hack from a safety standpoint. This was a partnership with AT&T that we did at one of the big hotels in Vegas recently. This was the second vehicle we brought to market. We were founded by many of you may have heard him speak, by a really bright individual named Jay Rogers. He was a Marine in Iraq when a number of his buddies died in a Humvee that was 15 or 16, or some of them even as old as 30 years old. And DARPA had a thesis that, open source, they'd seen sort of proliferation of Linux in running supercomputers and sort of that all with enough eyeballs, all bugs are shallow. He had a thesis that this was going to happen. Jay had a thesis this was going to happen in hardware when he was in Iraq, that we could get vehicles to market more quickly, that it shouldn't take 30 years to get what you need, and that you should be in the fight with equipment for that fight, not for the last one. And DARPA sort of picked up on this, and we were founded in 2008. In 2011, Regina Dugan, who's now with Google, called and said, can you produce a rescue and resupply vehicle for a specific region of Afghanistan that goes upwards of 100 miles an hour, is up-armorable, and can evacuate 3 soldiers in full gear in the prone? And can you do it on a micro-budget? And so we said, yeah, sure. And we got a bunch of sort of top brass together, and we were able to do it. And I'd like to tell a story, but the president tells it much better than I do. And so if you let me, I'll just play this video if we have sound.
Starting this summer, federal agencies will partner with industries to boost manufacturing in areas critical to our national security. I just saw an example backstage. The Defense Department scientists, we call it DARPA, the folks who brought us stealth technology, and by the way, who brought us the internet, wanted to see if it was possible to design defense systems cheaper and faster. So they found a small company in Arizona called Local Motors, and they gave them a test. You have 1 month to design a new combat support vehicle, and you've got 3 months to build it. Their CEO, Jay Rogers, is here today, and as an ex-Marine who lost a couple of buddies in combat, understood the importance of increasing the speed and adaptability and flexibility of our manufacturing process for vehicles that are used in field. So Local Motors solicited design ideas on their website, chose the best out of 162 that it received, built and brought this new vehicle here ahead of schedule. We just took a look at it. Not only could this change the way the government uses your tax dollars, because think about it, instead of having a 10-year lead time to develop a piece of equipment with all kinds of changing specs and a moving target, if we were able to collapse the pace at which that manufacturing takes place, that could save taxpayers billions of dollars. But it also could get products out to theater faster, which could save lives more quickly, and could then be used to transfer into the private sector more rapidly, which means we could get better products and services that we can sell and export around the world. So it's good for American companies, it's good for American jobs, it's good for taxpayers, and it may save some lives in places like Afghanistan for our soldiers. So that's what this is all about.
So this was really where it all came full circle for Jay. Left the Marines, and in 2011 was able to deliver this vehicle. The guy in the top left is Victor Garcia, who was an unemployed engineer in Detroit at the time. His wife was having a baby, and he couldn't afford to do that until he won this competition that we hosted on our website, and went on to get a job with Peterbilt. And this is key to sort of our open philosophy. At Peterbilt, he convinced his bosses that maybe they should work with Local Motors, that maybe there was innovation they could get from their consumers for their iconic Class 8 truck that is Optimus Prime. And so we ended up doing some work with Peterbilt later. So fast forward. This is sort of what we're best known for most recently, which is the world's first 3D printed car. Last year in 2014, over a 3-month period, we sort of just had this idea that perhaps we could speed the pace of not just development by open sourcing ideas, but in the manufacturing process. And so in September of last year at IMTS, the International Manufacturing Trade Show, we printed the Strati in 44 hours. And we had just, it was 3 months from the time we thought this challenge up, and 3 months later we printed it. And we did this in partnership with Oak Ridge National Lab down in Tennessee, who had been working on additive manufacturing for some time. And I'm about to play a video of how this works. Key to notice really is the honeycombing in the unibody there, because we often get questions about crash. And when you think about stamping steel, it's a blunt instrument for assuming you're going to get crash in certain directions. But this allows us to allay material wherever we want to put the material, and to, because it's a unibody, get crush zones in some very unique ways. This was a proof of concept that we drove off the show floor without the intention to sell to the general public. Go back here. It's made out of thermoplastic infused with carbon fiber, some of the same material that's been used in aerospace for years. It's a two-step process. First, we print it on the upper right-hand side there, which is, for those, well, you've just seen the process, but it's essentially laying material down on top of itself over and over again in layers. And then we mill it, so additive and then subtractive to get the soft surface, or the smooth surfacing, however we want it. Down in the bottom right, I've just put a picture of some MakerBots, which are really the consumer 3D printers that are available now. And the cool thing about this is we can make small models. And for the first time in history, schools and elementary school students and college students and PhD students and our engineers in our community, they're all working off the same CAD model. So you can print a small version that's using the same CAD model as the big version we're using. And so the iteration and the ideas that we're getting are coming from all parts of the educational spectrum. A few months ago, UNLV asked us if we'd print a golf cart, and a couple weeks later, we put this out, and they had a robot drive it around, and now we have partnerships with Arizona State, who's helping to characterize some of the materials we're using, as well as University of Michigan over at M-City, where they're doing some autonomous testing for us. Our first direct digital manufacturing microfactory is in Knoxville. next to Oak Ridge National Lab. There's month 1 on the top, month 5 down below. We're going to open that in a couple months. We're putting 50 of them up around the world over the next 5 years, and we've pretty much locked up every location already. Our first 2 international will be next year. Sorry. And then last week at SEMA, 2 weeks ago at SEMA, we introduced the first consumer model of the car that will be for sale in 2016, and this is the imagery of the winning designer, or the winning design. So I think that competition was won in June or July, and then this was the vehicle, the first swim that we introduced at SEMA last week. And the experience will be you walk into one of our microfactories, you walk up to a screen, you choose your body, your car body. This is the first one, but there'll be multiple. You'll choose your powertrain. We're starting with electric, but in South Korea, they want us to do hydrogen. In Berlin, they want something else. In Pennsylvania, they have obviously natural gas. You'll choose your components, your tires, your wheels, your color, and we'll print it while you wait, or for you to pick up the next day. And we call it upgradable hardware. So you'll see some various stories out there about the pricing of this vehicle, and people have been assuming that it's just a price to buy it, but it really is a contract by which you'll be able to bring the car back to us. We can strip the 50 components off it, melt the material, reuse it in your next vehicle for a small fraction of the price, or as part of the contract that you've purchased from us. And so getting back to the payphone, we're trying to think of new models for car ownership and ways to enable local communities to drive the future of their own energy paradigm. And so I think I'm well out of time, and there's so much more I'd like to tell you. I'll be around for the rest of the day. Thanks for having me. Oh, I'm taking questions. I'm taking questions. I'm sure there are many, so please don't be shy.
I have a question about the swim. If it gets in an accident, do you reprint the fender?
It depends on how catastrophic the accident, what the accident is. It's more economical for us to reprint the vehicle, to be honest, in most cases.
You can't fix it.
You can. It depends on the accident, and because we're just putting them on the road, we're going to be learning exactly which are better to just print the whole new vehicle versus what we can repair. But we know how to repair it. We're going to learn as it happens.
So how much is insurance then?
I'm sorry?
How much is the insurance then?
So it's a great question. We're working with a number of insurance providers, but these cars don't necessarily have residual value like other cars, because we don't expect people to keep them for 5 years. We expect to upgrade them into new vehicles, and we know exactly how much we can reuse the material. And so we think that the insurance is going to be a lot more like your cell phone, like a $6 a month type of situation. That's not the price of the insurance, but it'll be part of the contract as opposed to the way it's priced today. And some of the people in the room, I thank them for looking outside of the box and being willing to work on a new model with us. Any other questions?
So one of the things that traditional auto manufacturers spend a lot of time and money on is crash testing and so on.
Yeah.
So how do you think about and validate safety here? And is this thought of as a car, or is this a motorcycle from a legal perspective?
It's a great question. It's a car, and we're showing better crash data than some of our partners have ever seen, and that's specifically when I talk about that honeycomb structure and it being a unibody so that pieces aren't coming out of it when it crashes. And the other part of it is the iteration to safety, right? If we do a crash test and we don't like something, we change the CAD model, and that afternoon or the next day we've printed a different model and we're crash testing it again, as opposed to retooling or going back to the drawing board necessarily. We're finding that we can correct issues in a matter of hours or days as opposed to months or years. And so we're only going to put a safe car on the road, and we're well into that process. We will start selling these as low-speed electric vehicles, and followed a few months later once we have our certification as full highway vehicles. And what we're planning to do is actually those people who buy the low-speed electrics, we're going to upgrade their car into the highway version if they choose to be an early adopter on the low-speed level. So we're pricing it different, really, than as I explained, but it's going to be between 18 and 60,000, depending on the options you choose when you configure it yourself, or depending on the contract length that you're choosing for an upgradable piece of hardware. Yeah. I'm probably the wrong person to ask as far as the supplier, if that's what you're asking, or the material, but I can get you that answer. We use, I think, what others use, but I'm just not informed on what the exact supply. Yeah, sorry about that. Yeah, class. Yeah.
Could you tell me, hello?
Yeah.
Right here, over here.
Oh.
Question back here.
The drivetrain, how
Sure.
is that reused? Or is it reused?
It depends. It depends on the drivetrain and how sorry?
There's no printing of the motor and
Oh, no,
transmission or
no.
anything?
These are off-the-shelf components.
Okay.
We have some of the best suppliers in the world, German, Korean, and U.S. suppliers in the world.
And do you have listing of the
I'm sorry?
the participants in that?
Oh, we'll announce that very soon. It's just not, we haven't gone public with it.
All right.
But we we want to pass the choice on to the consumer on some level. Do you want this OEM's powertrain or this OEM's powertrain, and this is what it'll do for you. And so that's sort of why the pricing and is dynamic with the configuration. And what we've seen is people are really interested on being the Intel inside, if you will. We just announced or started some great work with IBM, as well as Microsoft and others. And nothing that we've given too much detail about, but I think that people see value when it comes to a connected car of being able to, well, we view the world as this is an accessory, right? Like that this is the Fitbit. The car is the Fitbit of the future. We're putting the sensors in that are required, and we do. Whereas I think most automakers aren't so sure that the phone is going to run the car, be the central nervous system. Local Motors is moving in that direction, and we're providing what we believe will be best in class on a rapidly improving basis, accessory type product.
So if you're continually iterating with this car, when you get to the high-speed vehicle, how do you plan to have it certified?
Sure. It's not that people can make changes that go unchecked. We have a head of engineering for each project that is on our website who's saying this is a good change or this is a bad change. There are strategies that we are working to make changes that don't affect our certification that we get from the beginning. Essentially, we're crash testing a skateboard that's going to meet, and it's a little more than a skateboard, but we're going to be putting different bodies on top of something that passes crash testing on its own. If that's the certification piece that you're talking about.
Since the SEMA show just ended, what are your thoughts on supporting the aftermarket with people printing their own customized car parts and things like that?
Their own cars?
Car parts, body panels, things like that. Are you guys embracing that? Are you guys?
Sure. I mean, I think we can't certify stuff that people print on their own, but we do believe SEMA's been so good to us. We've launched every car there, almost every car there, and we believe that the aftermarket is the modders. They're our family. The people that my dad grew up where he had an automotive class in school. Like I never had that because automakers didn't want people going under the hood. Your warranty would be void. And we're sort of taking a new approach to that. We want people to understand how to make this car. The Rally Fighter, you come to our microfactory, you build it yourself. If you work for another, anyone can come to our microfactory and participate in the process, see how it's done. And so we fully support people that want to learn how to do this and do it on their own. And I got a nod to the automotive industry because they've been doing rapid prototyping forever. They've just never really looked at it as a consumer-ready, as a commercialization strategy. And frankly, fair because the technology hasn't been ready for it. But it's getting there. It's getting very, very close. And I think Local Motors has decided to be out front. And we think people are willing and ready, if we can show it's safe, which we will, to start driving these things. Any other questions?
Speaks maybe to the the economic viability of this, because I'm kind of thinking that you've got a really expensive 3D printer. It probably takes a while to print a car, and you're probably getting small entrepreneurs to set up these microfactories. So, how does the economics work for them and for y'all?
Sure. Well, those are three big assumptions. Yeah, the machines are expensive, but that's okay. Tooling is expensive. Second, the entrepreneur, we're setting the microfactories up ourselves, and it doesn't take that long to print a car. We'll have it under, this is a bold statement, but our goal is to have it under 12 hours. Right now, we did the first one at 44 hours. 3 weeks before that, it had been, or 6 weeks before that, had been 180 hours. So, the technology is rapidly, and our learnings on a daily basis to increase the efficiency of the process are moving forward. So it will be a same-day type of transaction. And then as the economics work and just to finish up, we compensate our community on a royalty basis, just like the music industry is supposed to work or used to work. Where if you contribute to one of our vehicles, one of our products, you get a percentage of every unit sold. It's a small percentage, but people who participate in our process and have great ideas they bring to the table do participate in the economics. And to us, it's great economics because we're not spending $5 billion to put a product out. We can put 10 out, and if people like them, we can iterate and put another 1,000 out, and then put 100,000 out, and we can improve it each time. And that's why companies like GE and others see value in not investing in a product that they commercialize and then nobody buys. They're great at making one of something or 100,000 of something, but making 100 of something is not in their DNA, and then making 100 that are a bit different because they've gotten feedback from the beta testers or users. And it allows us to price the car dynamically. You're going to be able to buy this first swim if you buy one of the first few hundred at a lot cheaper price than if you buy number 2,000. And that's for us to incent people to get it in their hands and give us feedback, and we'll be very public about what that feedback is. And we want you on our site saying this is a horrible car, or this is a great car, or I like this part of it, or I hated this part of it. That's the only way we as a company make our products better. So I think I've taken more time than I've been allotted, but thank you, and I'll be around if anyone has questions.